Topic 2 is the remainder theorem and the factor theorem. Before we go into the remainder theorem and the factor theorem, let's look at some fundamental ideas. These ideas are going to help us with this chapter and other chapters as well. First, we want to talk about the difference between equations and identities. This is an example of an equation: x squared minus 4x plus 4 equal to 0. Look at the symbol, right? And observe what an identity looks like. Observe this symbol. There'll be three short parallel lines, and this is known as the left hand side of the identity, and this is known as the right hand side of the identity. Note, equations are satisfied by only certain values of x, whereas identities are satisfied by any value of x. So let's look at an equation first. Take note, you will see this quite often. LHS stands for right hand side and RHS stands for the right hand side. Now, if we look at the equation x squared minus 4x plus 4 equal to 0, we can go ahead and factorize this, and it becomes x minus 2 whole thing squared equal to 0, and you'll find x equals to 2, and this value satisfies the equation. X equals to 2 is called a root of the equation, or is called simply the solution of the equation. Now, like I said, only certain values of x satisfy an equation. In this case, x equals to 2 satisfies the equation. Now let's look at identities. The identity that I gave you earlier, we'll look at it, and remember I said that for identities any value of x will satisfy an identity. We will use this idea quite a bit in our course. So let's just say we have x equals to 4. Just pick any value. If you take x equals to 4 and you're going to plug into the left hand side, which was x minus 2 whole thing squared, and you'll get 4 minus 2 squared equals to 4. And remember, the right hand side was x squared minus 4x plus 4, and if you plug in 4, you'll get 16 minus 16 plus 4, and you'll get 4 as well. So we have got 4 on the left hand side and we've got 4 on the right hand side. Maybe 4 is not such a great choice for a value of x, so let's try another value of x, and let's look at when x equals to 5. You plug in x equal to 5 on the left hand side, you will get 5 minus 2. Oops, this is not a 3, this is a 2. I'll fix that in the notes. 5 minus 2 squared, 3 squared will be 9, and the right hand side, if you plug in x equal to 5, you will get 25 minus 4 times 5 is 20 plus 4, and you'll get a 9. The same value here and here. So for any value of x, the left hand side is equals to the right hand side. Now let's talk about polynomials. And what is a polynomial? A polynomial is a sum of terms of the type ax to the power of n, where a is a constant and n is a non-negative integer. So we have an example here, 9x cubed minus 2x squared plus 5x minus 2, and I have 6x to the power of 4 minus 3 over 4x plus 2. These are polynomials. We can see that these are all constants, okay, and these are all constants, negative 3 over 4 plus 2, and we have these are all integers, okay, 3 and a 1 and so on. So n is a non-negative integer, and we want to compare these with what's going to appear next, which are not polynomials. Now let me just scroll up a little bit. Yes, so if you look at this expression, we have x squared minus 3x to the power of 1 over 2 plus 2. The problem is here. Okay, this is not an integer, therefore this whole thing is not a polynomial. And if you look at x cubed plus 2 over x, let's open this up. We'll have 2 over x will be equal to 2x to the power of minus 1, and this is a negative number, therefore both of these are not polynomials. I'll repeat, they are not polynomials. Now let's move to degree of polynomials. Let's move to degree of polynomials. And what is the degree of a polynomial? The degree of a polynomial is the highest power of x that you see. Okay, so if you have x cubed plus 2x minus 4, the highest power of x that you see is 3, therefore the degree is 3. Now if you look at 2x squared minus 8, this is a polynomial of 2 terms. The highest power that you see here is 2, therefore the degree is 2. For example, I can write x to the power of 4 minus 3x squared minus 1. This one will be of degree 4, because the highest power here you see is 4. Now, next, let's look at what is the coefficient in a polynomial. If you have 3x squared minus 2x plus 4, 3 is the coefficient of x squared from here, negative 2 is the coefficient of x from here, and the coefficient of x to the power of 0 is 4, simply because 4x to the power of 0 is 4. And to summarize, if you have any term in a polynomial, ax to the power of n, a here is called the coefficient of x to the power of n. Let's talk about long division. We're going to approach long division by looking at an example. We are asked to find 2x to the power of 4 minus 3x cubed plus x squared plus 1, and we are going to divide that by x minus 2. Now in long division there are some terms that we need to be familiar with, and let's go and introduce ourselves to these terms. What we have in the box here, 2x to the power of 4 minus 3x squared plus x squared. Please note I have introduced plus 0x because you know there is no x term in the expression here. There's no x term here, so I've introduced an x to make the algebra simpler. This inside the box here is called the dividend. The dividend. This one outside here, x minus 2, is called the divisor. This is called the divisor, and what you end up with when you finish your long division is called the quotient. And let's go ahead and perform the long division. So once you've arranged this in this box-like form, take 2x to the power of 4 divided by x, you will get 2x cubed. Then what you do, take this 2x cubed, multiply by x, you will get 2x to the power of 4. Take this 2x cubed, multiply by minus 2, you will get minus 4x cubed. And what you do, you take this minus this. So this thing will go. You're left with minus 3 minus minus 4, which will be minus 3 plus 4. So you'll get plus x cubed. Bring this x squared down, and you'll have x cubed plus x squared. Do the same. Take x